Okay, so we're given some information and asked to find some stuff. We're given cosine theta is 5/13, and we're given theta is in quadrant 4. So we remember ASTC. All the functions are positive in quadrant 1. Sine, and hence cosecant, are positive in quadrant 2. Tangent, and hence cotangent, positive in quadrant 3. Cosine, and hence secant, positive in quadrant 4. And so we're given the value of cosine, and we're given theta is in quadrant 4. I want to emphasize just again, just to be sure, if this were not given, then we would not be able to solve this problem. If this is not given, all we know is cosine is 5/13. If this were not given, there would be two possibilities. See, look, this is a positive number. In addition to being a specific number, it's also a positive number. We know cosine is a positive number. What I'm talking about right here, later in the semester, when we're going to be dealing with solving trig equations, we're going to solve equations. If you cannot do this one little idea from way back here in week number 1, then when we get way into November, you're not going to know what to do to solve equations. Everything here builds on itself completely. So you need to get this down bedrock solid at the very, very start. You never have to worry about it again. Cosine is positive. Cosine is positive. So one possibility is we might be in quadrant 1, because everything's positive there. Another possibility is we might be in quadrant 4, because cosine is positive there. You think, well, what does that matter? Because look, when we find the values of the other functions, in particular, we're going to need to find sine of theta, and we know sine of theta is y over r. And if we are in quadrant 1, the y value is positive. But if we are in quadrant 4, the y value is negative. Here it's negative, here it's positive. And so there's no way to find the value for sine of theta if we don't know what quadrant we're dealing with. That's why this piece of information, or something else equivalent to it, something else that is equivalent to this information, there must be enough information given so that you know what quadrant you're in. There must be enough information so that you know what quadrant you're in. If that information is not given, you don't know what quadrant you're in. And in this case, I'm not going to ask this, but you might need to give two completely separate solutions, one for quadrant 1, one for quadrant 2. So we are given, however, theta is in quadrant 4, so we do know that the y value must be a negative number. We know because of this piece of information tells us that y is negative. That's going to come into play in an extremely important place here in just a moment. All right, so now, once we have all this in line, I always call this, to me, this is just draw the picture. Draw the picture, label the picture, it falls right in your lap. Because if you know the X, Y, R definitions, you're good to go. If you know the X, Y, R definitions, it's a piece of cake. So just draw it. It doesn't matter how, it doesn't have to be accurate, it doesn't have to be to scale, it doesn't have to be anywhere close to perfect. All we need is a quadrant 4 angle. That is good enough. I don't care what the lengths are, it doesn't matter. We're just going to label them and play with it. We know that we're given cosine theta is 5/13. We know what cosine is. That is x over r. So we have been given x is 5. We have been given r is 13. Whatever you're given, label in the picture. X value is 5. R value is 13. Y value, don't know yet. Pythagoras tells us that. So the next piece is Pythagoras. We got to find y. You're going to be negative. Y value's got to be negative. Find what we know that x squared plus y squared is equal to r squared. So that's 5 squared plus don't know yet is equal to 13 squared. From that we get 25 plus don't know yet squared is equal to 165. That gives us y squared is 144. And what is y equal to? Y is not equal to 12. Y is plus or minus the square root of 144. It is plus or minus 12, and you choose the appropriate positive or negative based upon what you're using in your particular problem, and it's right here. That's why we need this information so we can make this choice correctly, so the X, Y, R definitions all fall into place. And so we choose y is equal to negative 12. The rest of this is easy money. It's the X, Y, R definitions. We need sine of theta. Sine of theta is y over r, negative 12 over 13. Cosine theta we don't need because we already have it. Just find the value of the other 5. So we do need tangent. Tangent theta is y over x. Y over x, where's y is negative 12 over x is 5. Cotangent theta is x over y. X over y. That's negative 5 over 12. Secant theta. Really, once we have sine, cosine, and tangent, these you just need to form the reciprocal. So it's easy money. Very often what I will do is I'll just ask you for sine, cosine, and tangent, because I will assume if you have sine, cosine, and tangent, you know how to form reciprocals, but not all the time, so make sure we have it here. Secant is a reciprocal of cosine, so what we could just do is just reciprocal here. Or we know it's r over x, 13 over 5. And then cosecant, you can either know it as r over y, or it's the reciprocal of sine, but either way it's going to be negative 13/12. And those are the values we're looking for.